In this application, we're going to look at a tank holding some oil. The tank holds 60 gallons of oil, and over the course of 10 hours, all of it's going to drain out. There's a formula for the amount of oil remaining in the tank after T hours of draining. So we're going to call this V of T, V for volume, and it's given by 60 times 1 minus 1/5 T plus 1/100th T squared. We're going to find V and V prime at 3 different times. At the beginning, when T equals 0, after 5 hours, when T equals 5, and at the end, when T equals 10. And I'll also tell you how we can interpret each of these results. So to start, we're going to need the derivative for all of these cases. So why don't we find it? Why don't we find V prime of T? So we already know that V of T, or just V we can say, is 60 times all of this stuff. Now to find the derivative, V prime of T, or just V prime, you could, if you wanted to, distribute that 60 and then not have a set of parentheses. I know that we have said we can't have a product in finding the derivative. That is true, except for one product that we did look at, which is a product of a constant times variable stuff. And this 60 here, this is a constant multiple. So you can actually just leave it there as you differentiate. So in other words, what we can say is this will be 60 constant multiple times the derivative of the variable stuff which it's being multiplied by. So the derivative of 1 is 0. The derivative of 1/5 times t. Okay, 1/5 is a constant multiple in front of the t. So the 1/5 will be multiplied by the derivative of t, which is 1. I'll write that in. Then we'll add the derivative of 1/100th t squared. So 1/100th is a constant multiple again, but this time for just the t squared. So the 1/100th gets multiplied by the derivative of t squared, which is 2t. And we can simplify this, right? In the beginning, we still have 60 times all this stuff. 1/5 times 1 is 1/5, so we'll have minus 1/5. And then 1/100th times 2 is 1/50th. So 1/50th times t to the first. Okay, so these are the two things we need. We're just going to investigate what happens at the various times. So let's look at t equals 0. Okay, we want to find what's going on with the volume when t equals 0. So we're going to plug in 0 for just the in just the volume equation. So let's see, when we plug a 0 in for t, again, we're using this one here, or this one, just the volume equation. We're going to have 1 minus 1/5 times 0 plus 1/100th times 0 squared. Those are just 0, so we just get 60. 60 gallons. 60 gallons of oil in the tank initially. Right, when t equals 0, that's after 0 hours of draining. So there are 60 gallons of tank, 60 gallons of tank in the oil, 60 gallons of oil in the tank from the beginning, right? That makes sense. We were told that even. Okay, what is V prime of 0? Well, we'll plug in a 0 into the derivative. So initially, how fast is the tank draining? That's what this is going to represent. This is the rate of change of the volume over time. So when we plug a 0 in for t into the derivative, that part will be 0. So we'll get 60 times negative 1/5. So that's going to be negative 12. Now the units for a derivative, the derivative is a rate of change. right? It's like slope, change in y over change in x, or change in output over change in input. So this is the rate that the volume is changing over time. So the units of this is going to be gallons per hour. Gallons per hour. Why is it negative? Well, the volume is decreasing, right? It's losing oil in the tank. So what this means is that from hour 0 to hour 1, just in that first hour, from t equals 0 to t equals 1, the tank loses about 12 gallons. It's the amount that the tank loses in that one single hour. That is how we interpret the derivative. And we'll be doing a lot of this. So this is a bit of a first time for us doing this. Let me just make some space here so we can do this all at once. So there's V and V prime. Okay, I'm just going to highlight these so they don't get lost in our work here. So in the beginning, we've got 60 gallons, but in that first hour, the tank will lose about 12 gallons. Let's see what's going on in hour 5. So let's find V of 5. So it's plugging a 5 into the initial, or the original, just the velocity. What am I talking about? V for volume, into the volume equation. I'm sorry. So 1/5 times 5, right, plus 1/100th times 5 squared. Okay, and when we figure out what all of this is, check that you're comfortable doing this on your calculator. This comes out to be 15. And this is telling us the volume, so this will be 15 gallons of oil remain in the tank after 5 hours of draining. This is how many gallons are left. Right, let's find V prime of 5. So let's plug a 5 into the derivative. So it'll be 60 times negative 1/5 plus 1/50 times 5. Okay, so we're just plugging this into the derivative now over here, 5 for t. And what we get out is -6. And again, this is a rate of change of the volume. So this is, the units will be gallons per hour. So the rate of change in the volume, or the rate that the oil is being drained out, is different over time. So from hour 5 to hour 6, just in that 1 hour, the tank still loses because the rate of change of the volume is negative, so it's decreasing or going down. The tank loses about 6 gallons. Okay, so in the middle, halfway through, there's less than half of the amount left, and it's kind of draining more slowly, right? It's draining slower because we're losing less gallons over an hour than we were in the very beginning. So it's like all gushing out quickly at first, and then it's starting to slow down after that. Okay, then at the end, t equals 10. Let's find the volume after 10 hours. So we'll plug a 10 into the volume equation. And when you do that, you should get 0 out. 0 gallons. That makes sense because at 10 hours, right, it tells us that the tank will be drained. So when t equals 10, there are 0 gallons of oil remaining after 10 hours. Okay, let's see what's going on with the velocity. Oh my goodness, with the volume, with the rate of change of the volume. I'm sorry, I've made a lot of videos today. So v prime of 10. We will talk about velocity very soon. So v prime of 10, so let's plug in a 10 into the v prime. And when you do this out, you will get 0 gallons per hour, which makes sense because there's no more oil left, right? So nothing is draining out at hour 10. So the way that we would interpret this is from hour 10, in the 10th hour, hour 10 to hour 11, the tank loses about 0 gallons. Okay, so in the next section, we will dive a little deeper into the concept of the derivative telling us the rate of change of something. We'll actually talk about a couple different rates of change, but this is the basic interpretation of what the derivative can tell us in a context. It's how much the output is changing over like a unit increase, in this case, in an hour. So I will see you soon, see you next week, and I hope you are doing well. And if you have any questions, please feel free to email me and stop by office hours. I would really like to see you. Bye.